Ship A is traveling toward the lighthouse due west at a speed of 15 kilometers per hour. Ship B is simultaneously traveling away from the lighthouse at a speed of 10 kilometers per hour.
So we're going to start with the distance formula, which is square root y squared plus x squared. All right, now we're going to plug in our numbers. So our y is 3 kilometers. 3 squared plus 4 squared. And you're going to plug that into your calculator and get 5 kilometers.
First, we'll write the Pythagorean theorem. Z squared equals x squared plus y squared. Now we'll take the derivative of each variable in relation to time. Next, we will simplify by dividing each side by 2. And we get z times the derivative of z equals x times the derivative of x plus y times the derivative of y. All of this in relation to time. Now we will plug in the numbers that we have solved for. So z was equal to 5 kilometers. The derivative of z is what we're still trying to find. 4 kilometers for x times negative 15 kilometers per hour, negative because we're moving west, plus 3 kilometers times 10 kilometers per hour since we are moving north. Now we divide each side by 5 to, again, simplify and get the derivative. Negative 6 kilometers per hour. We want to find the rate of change of angle y, and we will do this by using one of our trig identities. Decide to use tangent theta equals opposite over adjacent. Our opposite is y and our adjacent is x. Now we will take the derivative of this equation, which is secant squared theta times the derivative of theta in relation to time equals, using our quotient rule, we find that it is x times the derivative of y over the derivative of time minus y times the derivative of x over the derivative of time divided by x squared. Now it is time to plug in our values. We know that secant is 1 over the adjacent over hypotenuse squared. So that is going to be... Now we can start to plug in our values. So we know that it's 1 over the adjacent over the hypotenuse, which is 1 over 4 over 5 squared, times the derivative of theta, which is what we were trying to solve for, and we're going to continue to plug in our values. So x equals 4 kilometers, and then we're going to plug in the derivative for y, which is 10, and then minus 3 kilometers for the value of y, multiplied by negative 15 kilometers per hour divided by 4 squared. Next, we will multiply by the reciprocal to get the derivative of theta by itself. And we will multiply each side by 4 over 5 squared. I will cancel on the left side. We now simplify the equation to get the derivative of theta over the derivative of time equals 4 times 10 plus 3 times 15 all over 25. We further simplify. We take out 5, which will equal 4, 2 plus 3 divided by 5, and this 1. Until we get that the derivative of theta over the derivative of time equals 17 radians over 5 hours. And that is it. Done! Done, 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 done. Go. Ship doesn't want to go anymore.
It was at this moment that he knew he
messed up.
You got it. This is the time. It's like 4. I'm gonna like hold it. It's like 4 degrees outside. Okay. Okay. I'm ready. Ready?
Ready.